This is Saurabh Mahapatra at PowerWorld Corporation. In this video, we'll take a look at using the PlayInGen model to stream certain time series data to a bus during a transient stability simulation. The example we will go through is intended to demonstrate an approach to power plant model validation and provide an overview of the relevant software capabilities in PowerWorld Simulator. We'll be using the Transient Stability add-on to perform the dynamic analysis, and we'll also be using the Model Explorer to modify some data in the network and transient stability sections. Now, before we can start using the PlayInGen model, we need to provide some time series data with it. In this example, we have some PMU data that was provided to us in a CSV file format. The columns correspond to timestamps, voltage, frequency, real and reactive power outputs, and the voltage angle at that PMU location. We have put this data in an auxiliary file format, which Simulator can recognize. From this auxiliary file format, Simulator can parse the PlayIn info, and the PlayIn signal objects, and those can later be linked to a PlayInGen model. We'll see that later in this video. The PMU data is from a high voltage bus of a generator. To emulate that, we'll be using a two-bus system like this. The high voltage bus will have the PlayInGen model to stream the PMU data. Connected to this is the step-up transformer and the low voltage bus with the generator that is being tested. The goal is to play in voltage and frequency values and then compare the real and reactive power outputs that the simulation calculates. We had two PMU datasets available, and we'll be using event number 2 for the demo in this video. It has about 30 seconds of PMU data. Now in this demo, we'll go through how to prepare the base case, modify the operating point, load the PMU data, and finally do the dynamic model assessment. So let's get started with the demo. First, I'm going to open up Simulator. In open case, I'm going to load in the EPC file that was provided to us. Next, I'm going to load in the transient stability data from the GEDYD file. In this case, there are 3 buses, which was originally set up as this system with a system side bus, a high voltage bus, and a low voltage bus. For our case, we only need 2 buses, so I'm going to modify this case. In edit mode, the first thing I'm going to do is move the generator to the high voltage bus. And I'm also going to specify a PlayInGen at that location. For the reactance value, I'm going to pick a small value. While I'm in this table, I'm going to turn off AGC and AVR at both the generators. In the buses table, I can delete the system bus. And I also need to set my low voltage bus as my system slack bus. For convenience, I like to relabel the buses. Now our base case is ready, so let's save it in a PWB file. The next step is to set the correct operating point. For the PlayIn generator, we are going to set the P and Q values that were provided as our initial conditions. And after some trial and error, we were able to figure out that the voltage at the low voltage bus needs to be around 1.083 volts per unit to match the initial conditions that were provided. We're going to solve the power flow, and we have the initial conditions for event 2. Now we will load in the PMU data from the auxiliary file that we created. The PMU data gets automatically loaded into the plane configuration under Transient Stability. We'll take a look at that. As you can see, the data is neatly arranged with all the column headers. And I've also specified a 10-second offset to the data, which means that during Transient Stability Simulation, the first 10 seconds will have no disturbance, and the PMU data will get played in after the first 10 seconds. The PlayInGen doesn't know which signals to play in at this point, so we need to go back to the plane generator, and we need to specify the plane file that we just created. And we also need to align the index value, specifying the column number for the correct voltage and frequency values to play back. Now we are ready to run the Transient Stability. We're going to go to Add-ons in Transient Stability. We're going to select an end time of 40 seconds and a time step of half a cycle. And we are going to go to Result Storage and change this number to 4, which will save 4 samples. It will save the data every 4 samples. That will give us about 30 samples per second. Now, before running the simulation, we are going to load in some plot configurations that I created in advance. This will help us visualize our data. Now we are ready to run the Transient Stability simulation. We're going to hit Run Transient Stability. And we see this error here, which says that the parameter TA of this exciter model needs to be 4 times that of the time step. This is a heuristic quantity which is predefined in simulator. For small cases, you can reduce this number down to get rid of this error, but I wouldn't advise this for large cases. So now that the error is gone, we can run Transient Stability. The plots show up. Let me expand these plots. The first row shows the high side frequency and voltage values which are being played in. As expected, these match the values that are being played in. The second row shows the real and reactive power outputs at the high side bus. And as we can see, the reactive power has a significant difference from the PMU results that we had gathered. And the real power has differences, but some trends are similar. And in this display, you can zoom in and look at specific time durations if you wish. So we looked at the steps to do this analysis. We prepared the base case, modified the operating point, loaded the PMU data, and conducted a dynamic analysis. So at this point, we have come to the end of this video. Thank you for watching, and please feel free to send me any questions or comments.